Okay, I read this question here, and I had to think sometimes you have to think there's different ways of doing probability, and sometimes you can use two or three different methods. Sometimes a tree diagram or a table. But after I thought about this one a bit, I thought a Venn diagram would be good for this one. Two people decide to go out one evening. They can see a movie or go to a restaurant, or they can do both. You see that or do both? I thought, wouldn't it be two circles and then have some space in the middle? The probability of the movie is zero point 0.5. The whole chance of the movie is zero point 0.5. The probability of the restaurant is 0.6, but the probability of just seeing a movie without going to a restaurant is 0.1. Hey, I could put that in a Venn diagram. What's the probability of staying at home? So this is how I did it. I started off like this, and I knew that the probability of a movie, this whole circle has to add up to 0.5. But I know that only a movie without going to a restaurant is zero point 0.1. So I can put the 0.1 right there. The chance of going to a restaurant is 0.6, so I can put it there. And you just do it one step at a time. If that's 0.5 and that's 0.1, that's got to be 0.4 because everything in the circle adds up to 0.5. So that's how you get the 0.4. And then once you get the 0.4, everything in the restaurant's got to add up to 0.6, so that's got to be 0.2. And then once you've got all of that, that's 0.5 plus 0.2. All the probability together adds up to 1. So you go 1 minus that 0.7, that's got to be 0.3. Now you kind of can use formulas to think about it, that the probability of only m plus the probability of m and r has got to add up to the probability of m. It's what I just said, but I put it in a formula. So 1 plus something is 0.5. I subtract the 0.1. That's how I get 0.4. And for the same way, and I get the same using the same technique to get 0.2. But what's the probability of staying home? That's just 0.3. You don't go to a movie or a restaurant at all. Well, the probability of movie or a restaurant is 0.7 altogether. And the probability of staying home plus the probability of going to a movie or restaurant, it's got to add up to 1. You go 1 minus 0.7. So you're kind of using formulas to get the same explanation I got here. The answer is 0.3, and you're looking at the probabilities in the Venn diagram. I think that's the easiest way. You don't even need all this. If you have a Venn diagram, you fill in those things, you're going to get 0.3. The chance of staying at home, or that's the probability of staying at home.